Good evening, everyone, and thank you for listening to the Futurati Podcast, where we dive into how emerging technologies will impact the world and your bank account. I'm Trent Fowler, and I'm bringing you a solo episode tonight. My co-host and I are futurists, keynote speakers, and consultants with decades of experience in analyzing trends and communicating new developments to audiences across the world. Reach out to us at futuratipodcast.com/contact-futurati if you'd like to hire us for consulting, to speak at your event, or to advertise on our podcast. So I just wrapped up an episode with Chris Mattmann, who is the Chief Technical Officer and the Innovation Officer at NASA's Jet Propulsion Laboratory. And he's just a fascinating guy, a consummate futurist who thinks a lot about emerging technologies and specifically about how different technological trends interface and interact with each other. So he's obviously a space guy, being at NASA's Jet Propulsion Laboratory, but he's got a long resume, long pedigree in artificial intelligence and data science, which are, my domains. It's what I do professionally. So we got into a fantastic conversation about what's coming down the pipe in space exploration, specifically some of the developments that will occur with future Mars projects and the possibility of developing a space internet and what some of the economic ramifications of that will be. Then we transitioned into a conversation speaking a little bit about Web3 and blockchain technologies and whether or not we're going to build a blockchain in space. And then we wrapped up by spending some time on large language models and generative AI and some of the ethical and economic implications of those technologies. Chris spent some time talking about how he's working with large language models and code completion in day-to-day work and where he sees that going down the line. So it's a really wide-ranging conversation. We cover a lot of different topics of interest to futurists. So I hope you find it as stimulating as I found it. And without further ado, this is episode 127 with Chris Mattmann. Tonight, we're joined by Chris Mattmann. Chris Mattmann is the IT Chief Technology and Innovation Officer at NASA's Jet Propulsion Laboratory, as well as the Division Manager of the AI, Analytics, and Innovative Development Organization in the Information Technology and Solutions Directorate. He works on ensuring that cutting-edge technologies support NASA's science missions. If you enjoy this interview, please subscribe to the podcast and share it with your friends, and don't forget to check out our website, futuratipodcast.com. Chris, thanks so much for coming on the show.
And thanks so much for having me. I really appreciate it, Trent. So, it's a pleasure to be on the Futurati podcast.
Fantastic. Let's hear a little bit about your background, your interests, and what brought you to working on the projects that you're working on today.
Yeah, well, no problem. So I'm the Chief Technology and Innovation Officer at NASA JPL. I'm also an advisory board member of Slingshot Aerospace. I've been since 2018. Work on a number of projects and do a lot of different advisory capacities, generally in the area of, everything from space to artificial intelligence to blockchain and crypto and, a number of other areas that are very interesting to me. I guess, probably the way I tell my origin story is kind of in three parts. Part one, I grew up in Santa Clarita, California. I was born in Los Angeles, California. Santa Clarita is about an hour north. If you've ever been to Magic Mountain, that's basically where Santa Clarita is. It's the Six Flags over here in the West.
Gotcha.
And I tell people, that's all that was there, 30, 40 years ago when I was growing up there. We didn't get a mall till I was about, 17 or 18, but, kind of a smaller town north of LA. And I grew up there. I was into computers, but I wouldn't call myself kind of like a computer nerd or anything. I would say
that other people call you that.
People ask me, in my job right now, they say, "Oh, have you been a computer nerd your whole life?" And things like that. And I'm like, well, actually, I was a sports nerd. For me, my dream, coming out of high school would have been to play college football, but I just never grew past 5'9". And yeah, everybody around me, I would say, the big challenge, was that they all grew and that I didn't. So, kind of growing up, I was into sports because I couldn't, play them professionally or at the college level. I kind of pivoted, and then for me, pivoting was sports journalism. And so I went into sports journalism and, basically did the yearbook for our high school for, junior and senior year. And then coming out of my high school, I basically applied to two schools for college. I applied to Michigan and the University of Southern California. So yeah, when I didn't sort of make it in playing college football, I applied to two schools to go to college. I applied to USC and Michigan, and it had nothing to do with the academic prowess of either school. It basically was, at the time in '97, Michigan had just won the national championship with Brian Griese, and USC was doing well and going to the Rose Bowl, although they had a bad year in '98. So I got into USC. I didn't get into Michigan. USC, the University of Southern California, moved there. And basically, this sort of leads into, how did I get a job at JPL? Well, back then we used to go on these weird bulletin board systems and look for jobs. And I was up in the computer lab late, one night, and I was tired of work study, working in the library. And there was a job from a company called JPL, not JBL, the headphone place. It was JPL. And they were looking for people that were good at database programming. And at the time, I had gotten pretty good at that. And so I was hired by an atmospheric scientist, Dr. Rob Raskin at JPL. I was hired to work on the Digital Earth project. And when I got to JPL, this was a pet project of Al Gore. And at the time, he didn't win the presidency. And so within 3 months of getting hired, my project was canceled. And so I pivoted, like we all do in the tech sector. And I started working on earthquake systems for some projects at Caltech. The first 10 years of my career, Trent, were really, I would say, the big data era. And so we moved to the era of, everybody is a sensor, everybody has an iPhone. So obviously everything in the social media, Web 1, kind of Web 2 space for that. But where we saw it in science was we all of a sudden had, instruments on our spacecraft, like the HiRISE instrument on Mars Reconnaissance Orbiter, that within a year would collect like hundreds, like 200 terabytes of data, and the entire size of the planetary archive before that was 4 terabytes. And we had a single instrument, single mission that just took us, it was, and then in Earth science, it was the same thing. The Quick Scat Siemens mission, a scatterometer that I worked on, after 10 years, it took 10 gigabytes of data, and its typical job processing workload was tens of jobs per day. And then I got thrown in the fire on a project called OCO, the Orbiting Carbon Observatory, and they said, well, the requirements for that are within the first 3 months, it's going to generate 150 terabytes of data, and it needs to process tens of thousands of jobs per day, nominal job processing. So, I'm sitting there, I'm a junior software engineer. I'm like, how am I going to do this? And they gave me some C code that used to work. And I was like, well, I learned Java. We were all learning Java at the time. And, I was in school, and I actually stayed on to get my graduate degrees. And my cousins and friends and, my academic cousins and people I was working with were part of this foundation called the Apache Software Foundation. And I looked at it. It was the hub for where all Java code was being developed. And I really just leaned in and became part of it and started, I said, this place you could leverage thousands of people around the world to build out software, real force, arguably the biggest force in the movement of open source for about 15 years. And yeah, I leaned into it. I got involved. I became on the board of Apache. I helped write a bunch of projects there and was a coder. I worked on Hadoop, Lucene, Nutch, SolarTK, Elasticsearch. I tell people, if you've ever searched for anything on the web, if you've ever clicked on anything, if you've ever done a business transaction, my name's in the changelog. And so, that was sort of the first 10 years, was leveraging that software to basically build out the next generation of NASA Earth science and planetary missions for the big data era. And I became the chief architect for instrument and science data systems. Here's the next 10 years, very briefly. You learn a lot about everything that's wrong with missions and projects, just in general in IT, when you work on them. And, basically I went around, I said, I have all these ideas for how to improve our missions and our projects. And I went around with my hand out to NASA, and I learned that, at the time I had a PhD in computer science, and I learned that they really like planetary geologists, but they look at people like me in computer science and they think that we're kind of the people that maintain the phones. And it's a challenge. And so what I found out on a $2.5 billion Mars rover mission is that I could get like 50K. I tell people I get 50K to build a database, and that's a challenge, that makes it very difficult. And so at the time in the Obama administration in 2012, the defense industry, the defense sector was getting a lot of money for big data. And so I basically engaged and started really working deeply with DARPA, the Defense Advanced Research Projects Agency. Was part of a number of programs with DARPA and other government agencies, including DHS, the Department of Homeland Security, and other places where there were cyber dollars. And I basically built a $75 million program to really accelerate and tackle some of these big challenges that we saw coming. Zero trust, AI, machine learning, defense in depth, the application of AI, to things like deep, eventually would be generators and generative AI. And so, yeah, we went very hard on that during that time. And I basically became a program manager and basically accelerated these technologies. And so the culmination of that was building out this particular technology called Tika, which is what the journalists use to analyze the data leaks from what they would publish as the Panama Papers, which won the Pulitzer Prize in 2017. And so that was like the big part of my second half of my career. And my third act that I'm now in right now is after that, I transferred to IT in 2017. Over the last about 5.5 years-ish, I was the deputy CTO and now the CTO for innovation, at JPL. And I run the division, that's really focused on AI analytics, future of work, AR, VR, and all of the things, I think, cloud, a number of things that people are interested in.
That is fantastic. I have several things that I want to follow up on as we move forward. I figure since we're both in machine learning and data science, it might be better to start there. So tell me a little bit about the endeavors that you're undertaking in that direction. Are you trying to build new approaches to machine learning or artificial intelligence and apply them? Are you just looking for ways to leverage known techniques? And feel free to work in generative AI as you see fit. That's the hot thing now. We'll TikTok it. We'll take that one part out, and that'll go on TikTok.
Well, I mean, maybe I should use generative AI to do the response. Let me see, but I've got Stable Diffusion open and ChatGPT. So it's sort of complex. Like I tell a lot of people, Trent, that JPL is not going to be DeepMind. We're not going to go out. We're not the place where we're inventing a number of those new models. We will, in some areas, and that's just because the nature of JPL. JPL is one of the United States national labs. And so the national labs started in the 30s and the 40s. There are places where you can do government work with civilian workforce, and basically they're supposed to do first of a kind things. So if you look at the national labs, sort of, with different government agencies, the DOE has dozens of them. They've got Brookhaven, Argonne, the Department of Energy. The DOD has Lincoln Labs, MITRE, Draper. NASA has one, JPL. And so because of that, the first of a kind things that we work on are the deep space network, the interplanetary internet, which is the way that all organizations here in the US, but also our international partners, really any major country that wants to communicate with assets in deep space that has access to this very shared resource, uses the deep space network. So we operate that for NASA. It's 3 70-meter dishes, which are football stadium size, in Canberra, Australia, Madrid, Spain, and in Goldstone, California. And so basically with the DSN, those dishes are how we command and also how we get data back, from our spacecraft. And so that's one of our key things. That's not commercialized yet. That's not, the commercial industry isn't doing that. Elon and Blue Origin and Bezos aren't doing that. The other thing that we do is we manage the Mars program. And, the United States through JPL and NASA are, besides the Chinese Zhurong rover that was only landed within the last year, and there are questions about whether they can even still communicate with that. The U.S. has landed successfully 6 times before that under that Mars program. So those are our kind of like first of a kind capabilities. So in that space related to AI and machine learning, just with that understanding, couple of different things. So we see a future where there are AI chips at the edge, for us. It's not true today. A lot of people think that those amazing rovers that we put on Mars have these amazing chips in them, and you're doing all this AI and machine learning there. We're not. The most recent example where we actually have an analogous AI chip, for things like that is the Ingenuity helicopter. It has a Qualcomm Snapdragon in it. So on the latest Mars 2020 Perseverance mission, the rover, and it's coring rocks on Mars, dropping these tubules eventually for Mars sample return, it also had a helicopter. The helicopter originally wasn't part of the core mission. The helicopter's called Ingenuity, and it wasn't part of the core mission. So if it failed, the mission wouldn't fail. And so we call that a tech demo. And so because of that, our risk profile on that was a lot, more accepting rather than our typical risk profile, which wasn't. So we put an AI chip on that. We put the Qualcomm Snapdragon, and there are all sorts of great things, in that feature. And we believe that, it won't just be a tech demo, and we're actually baselining for things like Mars sample return to have multiple helicopters. And we're baselining all sorts of different AI-like, GPU-like chips to use at the edge. Why haven't we used them before? Cosmic radiation. So we tell people, when you throw these chips up there into space, they get irradiated, and it flips the bits from zeros to ones and ones to zeros. That's a problem, when that's sort of the core communication language. So because of that, we haven't been able to put all these new chips. But now that we've kind of shown that we can, and there are chips that kind of can withstand cosmic radiation and perform like that, we envision a future in which we could do all sorts of things. Like, as an example, the DSN from Earth to Mars is anywhere from 8 to 20 minutes round trip flight time to send a message there and to get something back. And so because of that, Mars surface operations today is limited 200 images a day to decide where to go the next day. And so we've been working on a project over the last 3 or 4 years where instead of 200 or 300 images to decide where to go the next day for Mars rovers, what if I could give you 1 million captions? Text is cheaper than images to send over that very thin pipe from Earth to Mars. I could get more text back than images. What if I could give you 1 million captions? How could we get them? Well, we could run Google's Show and Tell, a neural image caption generator at the edge if we had those types of chips, on the rovers and things like that. And basically, what could it do? Well, it have to be validated. It would have to tell us like what's out in the distance, how far away, how many that there are, and things like that, which are all the different properties, that scientists want to look at when they're trying to kind of figure this out. They want to know, hey, what's out there in the distance? Oh, it's bedrock. Oh, how much of it? And how far away is it? It's 20 meters away and things like that. So we've been working on a model that we call drive-by science. That's a variation of that. It's a variation of the Google Show and Tell model. We've been testing it locally using our Athena test rover and NVIDIA TX2s, which are analogous, types of chips to the Qualcomm Snapdragon. And drive-by science is one of the examples that we're using. I could talk about others, but that's hopefully one that kind of, gets you out there in space.
That's fascinating. Are you looking at the possibility of building agents that can operate semi-autonomously in environments like Mars?
So right now, I would say the closest thing that we're getting to that is that the next big Mars mission is called Mars Sample Return, and it's not a single mission. You could think of it, and I tell people, it's like an interplanetary Amazon. Imagine if you needed an Amazon delivery service from here to Mars. Well, the first thing you would need to do is show that you could get something back. And so Mars Sample Return is a series of 5 projects that will demonstrate that. And we already have one of which, and 2 elements and assets to it, the 2020 rover and the Ingenuity helicopter, that are a key critical part of that. So what that rover is doing is it's pouring rocks, it's dropping these tubules, it's dropping them on Mars. And then what'll happen is our original plan was to have a fetch rover, which was a much smaller rover that had to drive farther and faster, Trent. And so it had to drive farther and faster, and it was a lot smaller. So the typical rover on Mars is car size today. It's like a Volkswagen Bug, about that size. This fetch rover originally was going to be about the size of a bicycle. And, the thing about that was that, it was going to have increased autonomy, increased coordination, because instead of traversing a couple kilometers a day, because Mars 2020 has been going for 2 years and the fetch rover originally wasn't going to go there for another 2 years, it would have had a lot of ground to make up for. We would spec it out for hundreds of kilometers a day, pick up those tubules, get those tubules to a rendezvous point, which is what we call Mars Ascent Vehicle, MAV, which is a big rocket that takes those tubules, gets them up and out of the atmosphere. It's going to meet Mars, I think it's called a Mars Entry Vehicle or something. I think it's MEV. I forget its exact name, but it's an orbiter around Mars that it would rendezvous with. And then it comes back, and then it uses Earth Entry Vehicle and Earth Entry Descent Lander to get back to Earth and get us those supplies back. So now, because Ingenuity was so successful, we are going to have 3 helicopters instead of the fetch rover, we've decided. And so there's a lot of talk right now that those helicopters will be specced out with whatever the next version of a Snapdragon-like chip is. And there's a lot of discussion right now about autonomous coordination in that particular context.
That's fascinating. That's fascinating stuff. What are some of the projects in the settling of space that you find most exciting? So over the past couple of years, we've done a number of interviews with people who are excited about the space economy, space tourism, possibly setting up manufacturing facilities in low Earth orbit. And I'm always curious about the economics of those things. It sounds really cool, right? There's certain kinds of crystals that form better in environments of low gravity, but I like to pick the brains of experts who are actually building these systems to find out which ones are feasible and which ones are, probably 50 years away. What are some of the things, in addition to the projects we've already discussed, that excite you about let's say the next 20 years of development in space?
This is a great question. Trent. And I would say that for me, it's basic infrastructure. I mean, some people say it's the economics, stupid, or things like that. For me, it's the infrastructure. And there's a lot of assumptions about infrastructure in space to even do some of these things. You talk about space ag, or things like that. You talk about some of these like you said, mining or mineral things.
Mm-hmm.
And the assumption, though, already for even doing things like that is that you have a reliable internet. And the biggest challenge that we have today is we don't have a reliable internet in space. I tell people, even with that deep space network, and that's just, again, it's not only for deep space. You can do near Earth, you can do other things, you can do lots of things with the deep space network. But there are various, spaceports, ground stations all around the world. But really what they're operating on primarily, 90+% of them, is radio frequency, or RF, which is speed of light like, but it's not as fast as optical and lasers. And so, like I tell people, the analogy is this: like, you do not have a one to none connection to your central office to the internet. It's not a single connection. There are 30+ hops along the way from your private home internet to your local office. And there's a reason for that: reliability, redundancy, all sorts of other properties to have a fast and reliable internet. And just basic things that we expect in these environments sort of depend on that. And so I think that a lot of these things that people want to do make the assumption that today we already have things like deep space optical comm, or even L2, or even out to the moon, or even just optical comm for that. And the closest thing that I know that they've done is there was a project with NASA called Opals to kind of demonstrate this optical comm on the ISS and other things. And lots of people are looking at optical, but there's still a barrier to entry because we don't have it. There's also space traffic asset management and some other things. But the big thing that I tell people is, if you want to get to these sort of next gen space verticals, we have to invest in really near moon, L2, and deep space optical comm. And I think it's going to come commercially. I think commercial is going to kind of drive this, to start. I don't think it's NASA or the government that's going to do this. They want to be consumers of it.
So that's fascinating. So it would not have occurred to me to go to communications over the internet as being the major bottleneck for the next iteration of space development. Why is that so important? I mean, I can make some guesses about the ability to communicate and coordinate on problems and things like that, but why is that the thing, as opposed to, reusable rockets that could fire 3 times a day or something like that? Why is that the big bottleneck?
Yeah. Well, that's a great one. And so it relates to an old concept from Vint Cerf called digital vellum. And I'm going to go back to the stone tablet era. But how many people today can grab a floppy disk from 30 years ago, pop it into a drive, and do anything with it? Very few. And many people, if I brought up what a jazz drive is, a zip drive, things like this, they'd say, huh? Or they'd react like, what? Like, what are these things? Media, the physical media has changed so much, just even our like physical asset storage media in the last 30 years, that it gives you an idea. And there was this real focus on, it's almost like software and hardware archaeology. And Vint Cerf gave a wonderful TED talk on this called Digital Vellum. But he basically said, hey, in the future, we're going to have to tell people basically, and possibly even store the operating system and everything required to run the software, including even the storage medium. We might have to have some way of storing the storage medium, to basically unpack it and get it out. Now, how does that relate to, deep space internet and all these things that I'm saying that you need? Well, I truly believe that, the genie's out of the bottle on the way we're doing software development nowadays. The way people are building, all of those use cases in space are going to require software. They're going to require business processes. They're going to require interactions that people behave terrestrially. They expect capacious network. They expect capacious, computing ability. They expect all of these things. And we're losing, in all sorts of areas, Trent, the perspective on how to operate with less. And that's okay in many ways because, it's allowed us to achieve all of these sort of great things, chat GPT, large language models, all of these different things would not have come if we didn't look at, what was staring in front of us, which was lack of bandwidth resources, and say, that's not a problem. We're going to, build one of these things in Amazon or Google that have all the access to it. And then we're going to figure out ways, instead of having everyone build one, of transferring that through open source or whatever to the public. I truly believe in the future, the way that software development, hardware business, space development is going, there will be the expectations. And from a skilling perspective in our people, this is what they're coming out, being trained in the space domain on. They're not being trained on how to program Fortran 77, how to operate in a low resource environment. They're being trained to expect certain things. And so we've got to give it to them. We've got to have the network there. We've got to provide them as close to terrestrial-like environments that we can have, so that when they're ready to make that next leap and bound, we can give it to them.
Hello, this is Trent Fowler, co-host of the Futurati podcast. One of the most common pieces of marketing advice I've come across is to know your audience and give them what they want. One difficulty in podcasting is that it's actually pretty hard to do this. None of the major platforms give us any way to reach out to you, our listeners, to find out what you enjoy about the Futurati podcast and what you'd like to see done differently. So we've decided to record this commercial and ask you directly to reach out to us. Head over to futuratipodcast.com, go to the contact page, and drop us a line. Tell us about your favorite and least favorite episodes, what you'd like to see us cover in the future, and anything else you want us to know. We produce this show for you, and we want your advice so we can make it even better. Thank you.
Could you walk me through a project that's not feasible today that would be feasible with interplanetary internet? What would that make possible? Just concretize it for me.
Yeah, well, I'll give you a couple of different examples. So today, there is a great desire, I think, in my generation to have the human explorer moment on another planet. It is since really the Apollo missions to have boots on anything of human, blood bag human beings on another planet or celestial body. Robots are fine. We've done it, but we would like, biological entities on one of these bodies again. Well, in order to achieve that, there is very much an understanding in today's 24-hour news cycle that if that were to happen, providing them after the fact, 8 to 9 seconds of video isn't going to cut it, of the people walking and things like that. We want real time, boots on the ground, live from across CNN and all the different, whatever, all the different media organizations throughout the world. And they're going to want access to it. They're also going to need a number of these capabilities, not just for real time video, but even comms. Because there's such a, basically this 8 to 20 minute round trip light time because of RF right now, in that 8 minutes, there's a great video on YouTube that just shows you how fearful we were of the robot dying. It's called 7 Minutes of Terror. And it describes the 7 minutes of entry, descent, and landing that is in that 8 to 20 minute window where we don't know if it's actually going to land, or if it landed. And could you imagine that with humans and actual biological entities and so on and so forth? So that's exactly why, Trent, that's just an example, with real-time video, why, we would need something like that.
That's fascinating. It speaks to the human need to narratize things and tell stories about them, and being able to connect with this mission in a very personal way will facilitate investment dollars pouring into the space. It will facilitate summoning the public will to move forward in these ways. I definitely buy into the thesis that's very important. Are there any startups that are working on this kind of thing, optical communications, that you're keeping an eye on?
There's a couple. Basically there was a startup called NXM that was working on secure internet communications related to this, and they're also focused on zero trust, as it's sort of related to that. So it's not just looking at that type of optical, comms and things like that, but it's also zero trust. That's been one that I've been following, in particular. But other than that, I'm not, the last time, I mean, I know that this is a big deal basically from 2013 to 2017 because I was working on Opals, at the time, which was our tech demo for it. But no, I don't have anything other than sort of NXM that I was tracking, but I know that there's a lot of interest in this space right now. And then also with the movement, in a couple different areas, realizing that network is important for other reasons, Trent, like IoT, 5G, and bandwidth and spectrum buys for that. There was a lot of interest, I would say, over the last like 5 years terrestrially that will matter in space related to that.
Are you enjoying this episode of the Futurati Podcast? If so, please like it, give the show a 5-star rating on Apple Podcast, Spotify, or wherever you get your podcasts, and share it with your friends. By far, the best way to help us grow is to spread the word on social media, which will expose our content to more people and help us continue to bring you interviews with world-leading experts in AI, quantum computing, cryptocurrencies, and so much more. Thank you in advance.
How does this interface with the problem of tracking assets in space? So this is something that just by dint of my day job, I'm paying more attention to, but it's also an issue that I've sort of tacitly been tracking for a number of years. There's a lot of stuff up there, and it's increasing all the time. And I've heard of a number of different ideas for tagging them or making license plates in space and that sort of thing. How do you think about that problem? And you're uniquely positioned to weigh in on it.
Yeah, well, so for me, I think basically, the big kind of interesting part is that there's a lot of traffic up in space, and that's, let's just start with that. That there's this famous sort of diagram, which is like that shows how many satellites are actually orbiting the Earth. And it just, I mean, people think like the Earth just like looks all nice and pretty until you see this, like what's actually orbiting the Earth. And yes, there are different vertical columns, and that sort of goes out into infinity, and things like that for that. But still, like if you look at what's orbiting the Earth, it's a mess, right now. And there's a lot of efforts thinking about just space tracking for space asset management, both commercially, because obviously everyone is just investing like crazy in commercial space and things like that right now. And so it's getting kind of crowded up there. As for kind of tracking, and technologies and capabilities to do that, the real big question is there a centralized authority to do it? And before, obviously Space Force and government, elements for that versus actual commercial capabilities, as an example, like that Slingshot or other companies are building. So is it going to be centralized, or is it going to be something, and that's from an asset tracking management perspective. Then there's all sorts of work right now. It's like the early days of the internet on protocols and standards, related to that. Is it going to use, traditional, I would say, Web 1, Web 2 technologies to do it? Is there going to be provenance? Is there going to be metadata models? Is it going to be related to space standards like CCSDS, the Consultative Committee on Space Data Systems, that has the standards for space telemetry, as an example, or things like delay tolerant networking, for ways for communicating in space. So there's a lot of work right now even on looking at the standards, for this. Or is it going to be, again, I think that a lot of the Web3 people would love for this to be a use case for blockchain, and this is where you hear people say, oh, when blockchain in space, or things like that, and they're kind of talking about that. So I think that there's a lot of room to innovate, in that space, Trent, and that's sort of where it's at right now.
So that is a nifty little segue into the topic of blockchain and Web3. I know that this is something you're hugely enthusiastic about, as am I. I've been at a couple of different blockchain startups, and it's a space that I've invested a lot of time in exploring. I do think there's a tendency sometimes when nerds get a hold of a shiny new technology to just try to do everything on it. And it's not clear to me that there's any real reason to eat the costs of decentralized ledger maintenance when you're talking about space data. So where do you come down on that? I mean, do you think blockchain in space even makes any sense? Do you want to do it just because it would be awesome? How do you think about that?
Yeah, that's a great one. Yeah, so a couple of things. So eating the cost of blockchain ledger in space just, more generally basically means paying the cost of like hashing and finding out, where the next block is and then propagating and updating that. And then given that I've just said that we're really bandwidth limited in space, absent there's a lot, let's just put it this way, there's a lot of networking, that has to occur after and communication and coordination even after doing those computations. So yes, like I don't come down on the realm that it's time yet for, deploying a distributed ledger in space to kind of solve everything. But this is also why, again, like I sound like a broken record, like, but then imagine a future in 10 years in which we went like a moonshot like project for deep space optical comm today. Like it's, you remember that sort of trend where people were, and it wasn't a trend, I think it was actually government investment. And it was even pre the existing administration, although it's really good, the infrastructure, bill and all that. I think it's benefiting a lot of rural communities, with bringing broadband to them. But there have been big efforts over the last 10 years, independent of U.S. administrations, where they've really been looking at how do we get the world connected, to the internet in places where it's not. I love that. I think, again, like, we're only limited, it's an idea economy right here on the world. I tell this to my son, we joke around, he's my little tough guy. He's, 14. And, we joke around. I say, might doesn't make right. And I say, it's an idea economy. And if you think about that, it's an idea economy. If part of the ideas that we could generate are limited by the fact that, certain people are using a string attached to a cup to communicate, whereas others are using, an advanced cell phone, like an iPhone, that's an issue. We want to at least get them on an iPhone, 10, maybe not a 13, but we want to get them up to an iPhone 10. Imagine what we could do if we could do that trend. If we had a moonshot investment in deep space optical comm over the next 10 years, my feeling is you could start to talk about, hey, polygon in space, or, a lower energy, low resource, and it might make sense. My big worry is that right now, when you look at, in my day, the infrastructure, the discussion, all about Hadoop, all about Spark, all about, all of these things. So you have a generation of people that came out learning Java, wanting the infrastructure, the core infrastructure to be in Java, whereas the surrounding fabric to be in Python, just from a programming language perspective. And because of that, look at how many decisions are being made just related to what people were taught. Okay. Mm-hmm. Now, the worry I have is people are being taught Web3 in class. They're being taught, blockchain technologies. That is kind of the infrastructure in a lot of cases, not solely. I mean, you still need databases, you still need things like that. But there's so much really education that's happening, even in JavaScript libraries and interacting and doing it in this sort of decentralized way, and wallets and all of these things, that I feel like if we don't find a way to focus that knowledge distribution that we've been doing, and we just leave them out on the island with the cup attached to the string, we're not doing a good job. I think we need to get them to where an even playing field, and I would love to see the innovation after that.
Do you need a dynamic and knowledgeable speaker for an event? Thomas Fry and me, Trent Fowler, are both seasoned keynote speakers, able to converse on a wide array of topics to audiences of all sizes and skill levels. Go to the contact page at futuratiepodcast.com to book Thomas or myself today, and let us apply our years of experience in public speaking to make your event a smashing success.
It seems like path dependency plays a pretty large role in your thinking. Like, this next generation of engineers and innovators who are coming online are used to low latency networks. They're used to expansive communication abilities. They're used to Web3 tooling. And a lot of your thinking seems to be geared towards trying to, give them the hammers and the drills that they're used to working with, presumably to lower the friction in the process and to make it easier for them to work. Do I have that right?
You do, Trent. And, it's so funny because, I was one of those people looking at, my predecessors, like, inventors of Postgres, who were crapping on us for MapReduce and things like that, and constantly dissing us. We did that 20 years ago, and I'm sitting here, you need to enable. And now I'm one of those people that really arguably is the older generation of people that innovated, looking at that new generation. And the big lesson I did learn, really two things, is to enable them, number one, and really, like you said, give them the tools that they need, because they really are the future. The other is, we're on a ticking timeline here. ChatGPT will fundamentally change, and large language model AI, it will fundamentally change the way people do code development. It really will. I mean, I sat there with a large language model, the ChatGPT, the other day. I'm the inventor of the Tika library. It's a very widely used library to do all the data file processing, and I call it the digital Babel fish. It can write very reliable Tika code. Okay, I can ask it to, and not just samples off of Stack Overflow. It can develop very complex things with that library. It can suggest things that don't exist even for the library, or places that, I might want to think about organizing the code. So before, I used to tell people, don't worry about integrated development environment tooling. It's really just there to help you. Why are you worried about autocomplete on your class function name or things like that? I mean, who cares? It's just productivity, right? And because the humans had all the creativity, your organization of your module and that's where it's coming from. I can't even say that anymore. I am so amazed by what these large language models can do, and their fundamental coming integration really to replace eventually integrated development environments, and possibly for, not even mundane tasks, even mild to moderately complex tasks, basically changing our need to write code for it rather than to simply become prompt generators, to really prompt these things to do that. I see a coming wave that if we don't enable this generation of and what they've learned, they're gonna miss out. They're gonna miss out. So
I share your enthusiasm for the large language models, and there's been some talk on Slack channels at Slingshot where we're demoing it and tinkering with it for the purposes of generating code. I asked it the other day to make me a Python script that could convert between a couple of different orbital frames. And it wasn't quite right. So it passed an argument to the function it didn't even use, and there wasn't a return statement. But like quite a lot of it was usable and impressive. And I'm curious as to the extent to which you're using it day to day. I mean, have you integrated it into your workflow yet? And I know some people have. So Amjad Masad is the founder of Replit, and he talks a lot about these things. And he says that when Ghostwriter, which is their natively integrated large language model for code generation, is offline, he feels as though 15 or 20 IQ points have been robbed from him. He's just noticeably less productive. So I think it will depend a lot on the things you're doing and how formulaic they are. But I'm curious as to what your experience has been like so far. I mean, are you using it a lot, or are you just sort of tinkering with it? How's it making its way into your day-to-day?
Yeah, great question, Trent. And so I am not using it a lot in my day-to-day activities. And my data scientists, I have almost 100 people in my innovation division at JPL. I would say they are actively, more actively trying to figure out how to leverage it day to day. And for us, I wouldn't say there's a lot of only formulaic things, but even like mundane or even some elements of creativeness, it can just do wrong. Here's the thing that I think people miss out on, and I wasn't thinking you were suggesting this, but I just don't want the audience listening to this to think it doesn't stop at the first prompt. So many people think you just type one thing to it and then you get it out. These large language models are powerful because they take the context of all prior conversation with them when they go to answer it. Where these things really shine is on the fifth prompt, when you're having a conversation with it and you say, "Ooh, you got that wrong. You used a function that you never called," and you watch it refine that, and watch it get closer, and watch it, and then the next time watch it not do that again. So this is the powerful thing, is it actually has contextual memory, which is really why these are 65 billion parameter models, like in the case of Llama, or things like that. I will tell you my not concern, but the challenge is with ChatGPT, and I can already see it's the fastest thing to 10 million users. It's great. I love it. I play around with that one a lot, but I have spent and invested a lot of time the last week or two into Meta's Llama, and I'll tell you why. You can run it locally. I can download the model. It's just a Torch model. And, I'm a TensorFlow guy. I mean, I spoke at the PyTorch conference. I gave a keynote. I mean, I wouldn't say I'm only one or the other, but I did write machine learning with TensorFlow 2nd edition. So I am very familiar with TensorFlow. That's my thing. But, I look at this, it's got a params.json file, it's got, it looks like a Python HDF, for all the, parameters or whatever, for its model storing. I can look at it, I mean, sure, it's binary, but I can use it. I can run it locally. I can do things with it. I have no clue what's out there in OpenAI. And so the challenge that I have with that is OpenAI and Sam, and all the people that are, the people that are running that company are great, but it is a company. And there are lots of checks and balances that they're putting and they're making and changing and tweaking with that model. Whereas if I use something like Llama, I've got it and I can tweak it and build it on my own. So companies that are going to put these large language models out and then start to do zero shot or quantization and make it even smaller and more compact, more runnable, that's where I think that is a game changer. That's going to be a fundamental, not just putting it out as a service, but like, give me the model. Let me have the model and play with it. Like that's more interesting to me. Like I discovered the other day with Llama, in its default examples, it shows you two things. It shows you that it has natively learned how to do language translation. Who knows how many languages? I mean, I had an ACL publication last year with a gentleman who was my PhD student at USC, who now is doctor PhD student and works at Microsoft. He joined their Translate team. But, his thesis was on a 500 to English or, any to many, basically encoder model, for translating 500 plus languages, which is 200 more than Google Translate does, to English. And, he trained it on TAC, Texas Advanced Computing Center. He had to do all the pre-processing work. It was basically his life's work thus far. And I'm looking at Llama, and Llama has figured out, can say in its default examples, they give it a few prompts for this word to this word in French, and it finishes the last prompt and figures out you're trying to tell it to translate, and then it translates it. The other thing I noticed is that you can give it a tweet that has sentiment analysis and a couple more tweets, and it'll do sentiment analysis for you. So all of these, and you didn't even tell it. You simply showed it some examples. So it's figured out you want it to do sentiment analysis, and that is wild. That is wild. So that tells me it's a multi-model ensemble. Like it's got logistic regression in it. It's got bag of words. It's probably got, different encoding models in it, so that is just wild to me, and I think we're going to spend the next decade unpacking even what these things have learned,
No, I completely agree. I've made the case before that this is something new. In a trivial sense, it's a continuation of technology we've been tinkering with since the 60s, and the very first neural networks and perceptrons and Minsky's work and all of that. But I very much of the opinion that at a large enough scale, quantity becomes its own quality, as they say. And this does strike me as something that's new and different and will have major impacts. I wanted to close out on a cheerful note by asking you about technological unemployment and AI safety. We can try to make that as compact as possible. I mean, those are huge topics, but are you at all worried about technological unemployment, this replacing coders in the future?
Yeah, I am. And I've told people this, it is definitely possible, and not just with large language models. I mean, who knows what now people are even thinking. And I've seen sort of two sides of it. I'll give it to you in art. We'll talk about the art real quick, and then I'll talk about my other kind of fear, or whatever. The art one, I know artists on both sides. We're talking about Web3. Web3 has enabled a lot of artists to, make money, whereas before it was very difficult for them to do that and to transact. And you look at art, you look at DALL-E, you look at Stable Diffusion, and so people are asking, hey, is that stealing the artist's images?
Mm-hmm.
And is that good or bad? I think a lot of lawyers are going to get paid a lot of money to answer and suss out is that good or bad in the middle part of it.
As is often the case.
As is often the case. But on the periphery, I know the artists that hate it, and I respect it. I understand why. It's probably the same in the beginning. I was a cassette tape guy, and I even have seen an 8-track and, put them in and out, even though I didn't really have one. It was my parents. But, I'm sure the artists and vocal recording artists back then were upset that you could copy those things and make a copy of a cassette. And I know that they were, and I know there's a lot of work into DRM that had to be done for that. So I understand that on the left-hand side, let's say artists. But then I know artists that have literally gone out and made a 25-slide deck where they're trying to break down how to use DALL-E and Stable Diffusion in their art to, what are the ways to get the prompts to do it what you want, and to save time. And so those are the ones that are leaning in and saying, my job as an artist is changing. Even if I'm a digital artist, it's not going to be go to Photoshop and all these things anymore. It's going to be to figure out how to combine that with maybe prompts and other things. So they're looking at the AI as an assistant and a helper. So there's that and that model. So how do we look at that next activity and make sure that it's transitionable, and we don't tell those artists to learn to code? Hate that. In that, in that vein, it's the same with truckers. I tell people, hey, in the next 2 to 3 years, down there in Texas, there's a gentleman named Elon Musk that moved his company there. And there's a very real possibility that on very long, 18 plus hour truck routes, which are perilous, fraught with peril, drivers falling asleep as well, that autonomous trucks will drive them. And that they'll do them in such a way that about 1 million truckers will be displaced. And so then the question is, what happens to those truckers? Again, and it's not learn to code. It's I think it's figure out not what their prompts are, but how do we get their SME knowledge into these trucks or these things that aren't going to know or have that contextual experience that they have. And we're going to spend a lot of time figuring that out. We ought to pay those people, high salary jobs, and give them that sort of transition off ramp. The last thing I'll say related to ethics outside of the context of upskilling and transitioning is, obviously bias. Obviously, the early smart cars, since we're on the topic of that, they did not recognize people of color because they weren't trained on them. They did not recognize people in wheelchairs. We need we need these things to be trained on data that represents us. And so we need DEI and A in there. We need balanced data. We need people looking at that. And we need the training data to represent us. The last thing that we need is, we don't want to hear the weather is going to be rainy here in Southern California. Oh my God, when they predicted that it was, going to rain for 5 minutes and then be sunny. We want their confidence with that. And we can give it. Predictions come with confidence. And too long have we normalized predicting things without telling us the confidence in it. That's the other element. We need predictions with confidence.
That's fantastic. I really appreciate you weighing in on those things. I think I broadly agree. We could probably do a follow-up episode just on those topics alone. So are there any final thoughts you want to leave the Futurati podcast audience with?
The only thing is that, we've been in a lot of places, I would say, Trent, on this, and it's been a just really enlightening discussion. I am more positive. People ask me, are you negative about the future, Chris, or more positive? I am more positive about the future. For me, we are, we don't have, well, we kind of do have flying cars in a way. If you go to the UAE or Saudi Arabia or Dubai, there are, those flying taxis that they allow on a test basis right now. But I think we're in the era of, we are closer to the Jetsons era than we know. I think, what we need back is our humanity, and we're getting it. I think people are kind of leaning into the humanity now, which is really nice because we're going to need it. We're going to need people to work together that hadn't worked together before and to figure out the next generations of advancements.
That's fantastic. Nice, hopeful, optimistic note to end on. Thanks so much, Chris, for your time and for the sparkling conversation.
Hey, thanks for having me, Trent. I'd love to come back anytime. Thank you, Futurati.